why don't we step through them and see how we go. So, number one, I just gave you a plain old rectangle, but it's just got one little tiny curveball thrown in there. Say it again. Okay. If you want Pythagoras' theorem to be involved, we need to set up this and this and this in a right angled triangle. That's useful because the area of a rectangle is length or height times width, right? And that 25 you've got there, what is that? It's the hypotenuse. It's the hypotenuse of the right angled triangle. It's the diagonal of the rectangle. We do use diagonals sometimes for calculating area, but not with rectangles. You don't need to. Those are far more easy to go for. So this is a 7, 24, 25 triangle, so Reeb has correctly worked out what the width is, and then he's just multiplied through. So good work. Number two, there was another extra step here. I've given you dimensions in meters, which means you can go from 1, 2, 3 to a 3-dimensional measurement, which is volume. So you can see that here in Brian's working. Yep, excellent. So what's he done on this first line? What is he actually calculating, this number? This is the
area of the face.
Yeah, fantastic. This face on the front, we would also call it, but like, why is it this face and not this face? Why is the triangle the one you want? It's the cross-sectional area, right? He's done the cross-sectional area. What's the second line doing? He's multiplying by... Okay, so you could describe this as length, and that's fine. I think a better way to describe it is as the perpendicular height. I know that's weird, because you're like, isn't this the perpendicular height? Mark.
No,
We get there. It's perpendicular to the base. For a prism, what we're interested in is perpendicular to the cross-section, which is right there on the front. Do you agree with that? Okay. So I actually think it's more helpful to call that the perpendicular height. From here to here, what's he done? This is the conversion, and you may remember we did this exact conversion yesterday when we said 1 meter by 1 meter by 1 meter. That's a really big cube, right? So every one of those has 1,000 liters in it. I just thought I'd show you, bring a prop. This cube here is exactly 10 centimeters by 10 centimeters by, I don't have enough hands, 10 centimeters. Okay, so 10 by 10 by 10 gives you
1 liter.
So just pedaling back a little bit, 10 by 10 by 10 gives you 1,000 cubic centimeters, which in turn gives you a liter. So I don't know if you look at that and think a liter. I always picture a milk bottle when I think of a liter, and this doesn't quite match, but because it's sort of thicker, that's why it works. Okay, so this is exactly a liter. This is a lot of those. All right, last one. Let's have a look at this solution. Okay, now this is really important. Who agrees with this solution? Show of hands. Okay, we've got a few hands up, but also a lot of hands down. So we need to sort out, is this correct or not? I could go through every line of working, but there's a quicker way, a more direct way I can check. Would anyone like to suggest to me? I can substitute back in, right? So let's just test this out. Over on the left-hand side, I'm going to try out negative 17. Negative 17 take away 3 on 4. Negative 17 plus 1 on 2. Okay, can you help me out a little bit? What's going to happen with this guy? What's this going to be? On the top, just tell me what the top is. This is negative 20. Negative 20. You divide by 4, that gives you 5. Negative 5? Negative 5, right?
Yes.
Yes? What about this one? Be careful, we'll worry about this part first.
16.
That's negative 16. When you divide that by 2, you get negative 8. But I'm subtracting negative 8. So that means this. Yes? Do you agree?
Yes.
So that equals 3. Is that what I want?
Oh, yeah. Yes. Is it? Equals
Tell us,
3.
sir, tell us.
Yeah.
The right-hand side started with a 3. Looks fine to me. Okay. Now, a lot of people didn't have their hands up. I just want to point out, because I'm interested when I was watching this working go up, there's a couple of things I want to point out. Maybe, I know some people will be like, what's going on? In particular, among other things, I'm looking at this line here. Now, Interestingly, there is actually an error in this line that we'll talk about in a second, but I don't know how, maybe just in writing. The error actually gets fixed up in the next line, which is why the answer is correct. Can anyone tell me what's the issue with this line? Can anyone tell me? Kate, what do you think?
It should be 4x minus 4.
Okay, so to understand why, I want us to think about what has this solution got? What's it doing from first line to second line? What's actually happening to change this into this? And Sarah's very helpfully actually written. What's she doing? She is multiplying every single object by the same number, which in this case is 8. She's multiplied by 2, then she's multiplied by 4. Do you agree? Do you see what she's done? It's easiest to see on the right hand side, right? 3, to turn that into 24, you multiply by 8, which works. Okay? But, I mean, Kate identified for us, this should be a minus 4. Why? Why is that? Any takers? Yeah, Cushy.
There's a minus in the minus, like the minus gets carried over.
Okay. I want you to repeat that again, except I want everyone to hear that because it was exactly right. And there were like 5 hands up for people who agree with Sarah's solution, even though it's perfect. Okay? So, with attention, could you repeat that again about this minus sign?
It's like when you minus like across, like the minus gets carried over and it isn't a plus anymore.
Okay.
It's just a minus.
So this is a bit tricky, right? This minus sign, it applies to the entire fraction. Do you agree? So even though I haven't written it, there's kind of brackets here. Do you notice that? They're sort of implied, but I don't have to write them because it's one fraction, right? Therefore, on this next line, this minus sign applies to everything inside the brackets that sort of aren't there. So minus 4x, but there's also a minus 4. Now, do you notice? I don't know how intentional this was, but she's actually fixed it up here. Because see that minus 10? Do you see that's actually correct? Because minus 6 minus 4 is in fact minus 10. Do you notice that? And that's why the answer is correct. Okay. Let me point out one more thing, because I agree with the solution. Sarah chose at this point here to multiply by 8. And it works out. You can actually multiply by anything you like. You can multiply by 100 or 50 billion. Everything will still stay fine. Multiplying by 8 though actually makes things a little bit harder than they should be, because I can multiply by a smaller number that still fixes everything up. Not a rhetorical question. Why is she multiplying by 8? Why 8 and not say 9 or 11? Yeah, Ellen.
Because she was looking at the two denominators of 4 times 2 is 8.
Now you can see the lowest common multiple
It's actually
will get rid of these fractions. That's what she's trying to do. That's why the second line is much better than the first. There are no fractions there. Okay. However, the lowest common multiple of 2 and 4 is not actually 8. It's 4, right? 4 is a multiple of itself, and 4 is a multiple of 2. So I can multiply everything through by 4 instead of 8, and it will come out quicker, the numbers will be easier, okay? But this is not wrong, like this is still big thumbs up. There's a lot of work in there. So good job if you got that negative 17 to the 5 or 6 of you who did. Not an easy question, okay?